So today I'm going to talk about some of the problems we face at Google, and where big data is especially relevant to helping solve these issues. I'm going to focus on search and search ranking, and then talk a little bit about an app we just released called Gboard. Gboard is an iOS keyboard where we spend a lot of time kind of building from the ground up a keyboard that's able to predict what you type and autocomplete your words and is as accurate as we can make it. So we get billions of queries a day. Every day we see queries we've never seen before. We see about at least 15% of the traffic we receive are brand new queries we've never seen before, and we have to be able to develop algorithms using the signals and the data that we have to be able to find answers for each of these queries. And for what I'm showing you on the left here is the query, why is the ocean blue? And we've returned an answer from the NOAA's website that tells you why the ocean is blue. And behind all of this is our core ranking algorithm, which understands what users are asking for and is able to surface answers from the billions of documents that we have in our web index. One of the problems we face simply building our web index is, well, which of the billions or even trillions of web pages that are out there on the internet should we crawl and should we index and keep accessible for our users? And then, how often should we recrawl these pages? And as we try to solve these problems, we look at the data in terms of how often these certain pages and certain sites are impressed and are clicked, and try to model and predict whether a new page that we're crawling is going to be one that would be useful for users in the future. So as you look at some of the features that we build into search and some of the experiments that we run, here's just like a screenshot of what our desktop search looked like I think about a year ago. It's probably similar right now. The query is Bakery, Durham, North Carolina. We actually evaluate every single component and experiment with every single component of this search results page. So on the left-hand side, you see a list of web results. These web results, we run a retrieval algorithm where we retrieve web pages that we think might be relevant. We rank them, and then we display them in a manner that we think is consistent with what users would expect and making it easy for them to interact with our search results. And every component of that is individually and holistically kind of experimented with. And I'll talk a little bit about how we go about that experimentation process. We also have ads on the right-hand side here. We run experiments with ads, as well as the UI and the look and feel of our search results page. The important question that we always ask ourselves in search is which way is up? What makes a better search engine? What makes a better ranking function? Or what makes a better UI for search? What features are good for our users? And the difficult problem with this is that there isn't necessarily a gold standard that we go by to determine what our true north is. What we've been able to do is, over the last 15 years or so, kind of solidify our vision for what we want our search experience to look like, and try to encode that in guidelines that we provide to human raters. And these human raters provide us feedback on our experiments. So what we're able to do is run experiments, provide examples of these experiment queries that are affected by these experiments to our human raters, and then they're able to kind of help us evaluate whether a particular change is positive in their trained opinion. And then beyond that, we run live experiments on real users as well. So I kind of want to show you a little bit what these. Let's see, how do we get to this tab here? Let's see, I'm just going to click. I'm going to show you what these rater guidelines look like. So reloaded here. So it's kind of we're encoding here instructions to what we believe are important for our raters to evaluate, and I'm going to just show you one section of this. These are your money or your life pages. So some types of pages could potentially impact your future happiness, health, or financial stability. We call such pages your money or your life. So we actually spend a lot of time training our raters to make sure that they value authoritativeness, high-quality content, especially for queries where authoritativeness, trust, and quality could make the difference between a great experience and a pretty poor experience in search. And this document, this kind of guideline for how we think about search has evolved over time with respect to our thinking for what makes a good search engine. So recently, we've started focusing a lot on mobile friendliness and encouraging our raters to spend a lot of time evaluating whether a page is friendly on mobile devices. Does it load quickly? Is it easy to consume? And then beyond that, continue to focus on whether sites are authoritative, whether they, if it's a retail business, does it get good reviews? Does it have a telephone number that's obvious, or contact information that's obvious on the page? So all kinds of properties that we think make a high quality web page are asked of our raters to evaluate. Now, these evaluations aren't used directly in our ranking function. They're used just to help us understand whether changes to our ranking function are good. But the reason that I brought it up here is to show that there isn't really a single objective metric that we're trying to optimize. We're really trying to encode what we think is good in a search engine and hopefully iterate over time and get there. At the same time, though, we run live experiments, and we make sure that whatever we build has a positive, hopefully has a positive impact on users. So I'll show you like a little graph we put together. This kind of goes through, this is data from 2012, so it goes through the process of of the experiments we run and at the scale at which we run these experiments, and the funnel through which we come up with ideas and evaluate them. So the top number there is 118,000. So we ran in 2012 118,000 what we call precision evaluations, where we came up with an idea to change our ranking function or our UI, and we asked raters to determine whether they thought that that change was good. And so they evaluate each result, and they say, you know what, this change I think is better or worse than what we currently have. And then we also run these side-by-side experiments where we ask our human evaluators, well, do you think the left side or the right side is better? Where the left side might be the experimental side, and the right side might be what we currently have in production. And then they evaluate. And they evaluate based on these trained guidelines that we give them. And finally, we ran 7,000 live traffic experiments in 2012, where we actually take a small fraction of our production traffic. Presumably each of you were also in these live experiments, and we evaluate to see how users interact with the experimental, the ranking function or UI that we're evaluating, or the control or the production UI that we're comparing it against. And we develop metrics like click-through rate, or how many interactions are on the page, how often you manually refine the query, and look at those metrics to understand whether we think that the change is good. And finally, in 2012, we had 665 different changes to our search algorithm, either ranking function or UI or new features that we launched, all of which almost all of which we ran side-by-side experiments, live traffic experiments, and went through the whole funnel. Now, the decision as to whether we actually launch a change doesn't necessarily come down to only whether we saw positive live experiments or positive human evals. It's certainly still a little bit more complicated in the sense that we also have to think about the potential impact of that change in the long run. So the potential impact of that change on the web ecosystem, the impact of that change on for example, whether we're promoting small sites versus big sites. Are we doing the right thing in the long run for the ecosystem that Google's built on top of? And oftentimes that comes into play when we make these decisions. So I wanted to dive in particular to one of these components. This is the component that helps us understand what users mean when they issue a query to Google. This is one of the components where we use the vast amount of data that we have from the web and also from our search query logs to be able to improve your searches and to be able to, one interpretation of it is to be able to apply our natural language processing ability at scale to hundreds of languages that we support for Google search. So we'll talk about synonyms. So the background is that enabling computers to understand natural language is still one of the hardest problems we face. It's one of the hardest problems we see in artificial intelligence at all. I think you're starting to see this with some of the bots that are coming out this year and these bot platforms that many of the messaging apps are supporting, that having a natural language conversation with a machine is still very, very difficult. We're still at the early stages of making it feel very human and real. But for Google Search, it's critical for us to return the best results. We have a very native entry point to search where you can either say or type anything you want, and very often the natural thing to say or type is by speaking in your natural tongue, in your natural language. So in order for us to understand these queries, we need to be able to rewrite them into a language that generalizes and we can understand. So synonyms is a big part of that. So what is a synonym? Some are obvious. So, for example, pictures and photos mean the same thing in most circumstances. If you search for pictures developed with coffee, let's see if I can click on it. Pictures developed with coffee. Did you know you could actually develop photos with coffee grinds? You can do that. So someone searched for the query pictures developed with coffee, and the first result here is how to develop film using coffee. Right, and then you can see in the URL we actually highlight the word photo, and the search query had the word developed. We highlight the word develop. So we highlight the word develop. We highlight the word picture, probably photo a little bit more. Let's see if we can scroll down here. Pictures. So we're synonymizing the original query. Here's photo in this result. So we're synonymizing this original query with synonyms like picture, photo, develop, that aren't exactly represented in the user's original query. And because we're synonymizing, we're able to pull up websites and results that might be higher quality and that we think might be more useful for our users. Pictures and photos is a pretty obvious example, though, where it gets more Where it gets more interesting is when we have to scale this to terms that might mean something in different contexts. So we use the petabytes of web documents that we have, the billions of examples of search queries that we have, to build this intricate understanding of what words can mean in different contexts. So photos and pictures even can get more complicated if I talk about, if the query is history of motion pictures. Motion picture is a concept, right? You wouldn't want to synonymize motion pictures to motion photos. Motion photos doesn't make sense. Motion pictures does make sense, and you might want to synonymize motion pictures to movies, right? So a great web page about the history of movies would be relevant to that query, but a page about photos is probably not relevant to that query, so you wouldn't want to return it. And we can learn that through mining our web data, mining our search data, and developing an understanding of how language is used in different contexts. Another example is GM. Absent of any context, you might think GM means General Motors, but certainly if somebody says GM cars, then GM you would want to expand to mean to include documents that simply say General Motors. But what if I said GM wheat, right? Then maybe the context there is that GM should mean genetically modified wheat, right? And there's all kinds of other meanings of GM as well. So if I said GM University, I might interpret like George Mason University, that is George Mason University, or an NBA GM would be a general manager. So depending upon the context, you might want to synonymize differently. And you can imagine that in order to be able to do that at scale, to the millions of terms there are in English and in all of the other languages we support, we have to be able to mine the data that we have through the web and search logs to make it work. So what we do is we look across the billions of searches that we have, and we apply different algorithms to that data. So for example, one of the approaches we take is we look to see how often users replace one word with another in a particular context. So if I see the search query GM cars, I might also see the search query General Motors cars closely after it, and now I see that, well, the user replaced GM with General Motors, and now we think there's some relationship between GM and General Motors. We have to be careful, though, because what often happens as well is that somebody might be shopping for different kinds of cars. So someone might type GM cars, and then they might also type BMW cars, right? And we don't want to assume that GM and BMW are synonyms, but that's often the case that we see in our logs. So it's one pattern of losses that we would find by using that approach, and we'd have to address that pattern of losses, perhaps using another algorithm or another signal to help us differentiate those cases. And that's part of the process by which we develop changes, is by thinking about an idea, running an experiment on that idea, and looking at these experiments that we run, these human evaluation and these live experiments that we run, to really understand whether we're in general doing the right thing, and see what the patterns of wins and losses are. And if we see a pattern of losses that's common among each of the loss examples that we have, then we can try to address that in a follow-up change, or even try to modify our algorithm to improve. So finally, like, one of the big wins from using search queries as a source of information for synonyms, as opposed to simply the web, is that we're able to incorporate kind of colloquial language, usage of language and idioms more easily than if we use formal text. So having a source of data that matches the application that we are going to use that data in is critical. So, and we'll see how this plays out as well, actually, when I talk about Gboard later on. The ideal case is that you're able to use a source of data that's similar to the context you're going to apply it in. For Gboard, we don't necessarily do that in the first iteration, and you'll see how that what the effect of that is. Okay, so the last thing in ranking that I wanted to talk about was how we think about spam. Spam is one of the early successes of us building classifiers to help us understand and detect websites that are either actively trying to trick our bot or that are hacked by, like that are hacked sites so they don't represent what they used to, or they're trying to SEO their content in a way that violates our guidelines. So, for example, can we detect whether a site has been hacked, and we have a classifier for that? Or can we detect whether a site has hidden text or is keyword stuffed? So it has words on the page that isn't visible to the user, but they're there simply because that webmaster wants that page to rank for those terms. So these are just a few examples of where we use the billions of documents on the web, the billions of search queries that we get to be able to build classifiers that help us better understand whether a page is potentially violating our guidelines or in general isn't useful for users because it's hacked or is cloaking or whatnot. So some of them are easier to detect than others, but these are the different problems that we face that we build signals for, algorithms for, and we run experiments for to determine whether they're good enough or not. So in this section, I wanted to talk a little bit about our philosophy when it comes to search and how machine learning fits into that philosophy. Search is a global product. Google search is a global product that's used in 100 languages, 100 countries, and it's important to the fabric of how many people around the world get information. So a system of that scale and that impact has to be human understandable. And the reason it has to be human understandable is that we have to understand as engineers at Google why we return the results that we return, why we return the answers that we return. We have to understand why we return answers that are correct as well as answers that are incorrect so that we can understand why things are working and why things aren't working. Understanding our system enables us to see why we're doing the right and wrong things and fix these patterns of problems by coming up with new signals and new algorithms. So when we think about machine learning in search, we have to be conscientious of the pros and cons that it brings. So hand-built systems, where like Google search ranking is largely today, is human understandable. So today, for almost any search query that you might issue, I or another ranking engineer can understand why a particular result is ranked or why a particular answer is given in the first position. One common issue with machine learning is out of the box. Oftentimes, it's rather opaque. Or if we applied a machine learned algorithm for search, we have a harder time understanding, well, why exactly, what signal was responsible for us returning that answer. Now, in some contexts, opaque systems are okay. So, for example, if the metric is well defined and agreed upon, so if it's a very concrete metric, there's a single metric that we can trust as our true north, as the way that we think search is going to get better, then then maybe it's a little bit more okay to have an opaque system behind it, because we can simply try to optimize that single metric and know that we're moving in the right direction. So in the context of a keyboard, word error rate might be that metric. How accurate are you with the keyboard? But relevance in search isn't really well defined. Like our metrics in search only capture a part of what our overall user experience is. We have human eval metrics, we have live experiment metrics, but each of these are limited in what they can represent. Human evaluators don't represent users. Users don't always know what the most useful results are before they click on them. And they have a hard time evaluating, oftentimes, what the most authoritative content is. So it's not an exact science. And beyond that, like I mentioned earlier, we have to think about, with respect to all of these changes, what's the impact on the ecosystem we're built on top of? If we make a particular change, are we promoting content farms to develop more long-tail, low-quality content? Or are we unfairly biasing large, prominent sites versus small sites that might be equally authoritative and equally high quality? And these aren't currently really measured through live experiments. They're not directly measured through our human evaluators. Some are and some aren't, but it's a difficult problem. So we need to look at the individual query examples. We need to understand what the patterns of wins and losses are, and try to make a decision as to what we think is the right change. But that said, machine learning can bring huge wins. It allows us to encode thousands of weak signals into a single system that can put them together and produce a very big win. It can do this by helping to identify non-obvious ways to combine signals, signals that we wouldn't have thought to include, like I don't know if I have any examples, but certain terms in the title of a web page, and it helps us scale our use of data to apply algorithms on large data sets without through natural algorithms that we're developing, like our Google Brain machine learned neural networks. So what we started to do over the last year is spend quite a bit more time thinking about machine learning and thinking about how we can build machine learned approaches and tools in search that we can understand. And that's the challenge that we face, and that's really where we're spending a lot of our time. Can we understand how a machine learned approach like RankBrain, which is an algorithmic change we launched last year, how that affects our ranking, what are the patterns of wins and losses, what exactly is it doing? We spent a lot of time understanding each of the components to that neural network and making sure that we think it's doing the right thing. So simply using machine learning, applying it to an objective function, and launching it is certainly out of the question unless we actually understand what's going on. So finally, with respect to search, I wanted to just focus a little bit more on what the challenges we face are. Whenever we do these evals, they're done on a cross-section of the current landscape. We take the current web ecosystem and we run an evaluation maybe for a couple of weeks as a live experiment. We run these side-by-side human evaluation experiments, and we determine whether it's a good thing or not. But we have to be conscientious of the fact that changes to how we rank content often affect the ecosystem we're built on top of. And some of this, the effect is intended. We make changes to encourage web developers to build mobile-friendly content, or we make changes to encourage developers to deep link their apps so that users can directly navigate to content within apps, or we make changes to encourage developers to make their sites faster and to make their sites more secure by using HTTPS versus HTTP. So some of the changes we make, we intentionally encourage a directional change on the ecosystem, But far more, we have to think about what are the unintended consequences in the long run of some of the changes that we make. So this remains a challenge because we have a hard time at a given point in time predicting and understanding what the long-term impact will be. So there's a very human element to what we think our true north is and what we think a good change is. And that's still in place in a large part today, even with our focus on machine learning. So I want to talk a little bit about Gboard. Gboard was an app that we just released. Gboard is built inside the search group, mainly because the technology that we use, and I'm just going to show you what Gboard is. It's an app on iOS that you can download on the App Store today. It's a keyboard that allows you to do something called glide typing, where you can drag your finger around the keys and it'll predict the words that you intended to input. And of course, there's millions of words, and we have to build and understand a language model for these words to be able to do this prediction. And it's in search because, in search, like I was talking about earlier, we think that we understand language pretty well. The keyboard is a very different application of this, but still it uses similar techniques to what we use in speech recognition when you issue a voice search to Google, and similar techniques to what we think about when we when you issue a search query to Google, even by typing it in. So with Gboard, you might gesture a word, and that registers as touch points. We have a particular keyboard layout. This is our Android layout, but similar layout on iOS. And then we send it to our decoder, and we have a spatial model to understand, well, what's the probability spatially that you meant one character over, or you meant one character over another. And then we run it through our language model, which helps us understand what the overall likelihood of a particular word in the context of the bigram or the trigram of the words before it, and maybe even after it, are. And then we provide suggestions based on these words, or based on this model. So with Gboard, though, how we bootstrapped it was by using words and sequences of words we found on the web. So these are public words, and when you download it for the first time, it's based on a model that's largely trained on pages that we find in the web. We mine billions of web documents, build a language model to understand the n-grams that we see commonly on the web, and use that as our default model. And then over time, what happens is it learns based on your own words. So you might use certain colloquial phrases, and it'll learn your application of those phrases and the bigrams and trigrams that you use them in. And so the quality improves, and it gets better over time simply using your own data. Now, of course, like I mentioned earlier with respect to synonyms, using search logs to improve synonyms, ideally it's the case that we use conversational data, we use chat data, we use keyboard data to improve our bootstrapped or initial language model. And we're starting to think about ways we can do that. So I think that's it for oh, sorry, one more slide. The other part of Gboard I want to talk about are certain new features that we built that involve new ways of thinking about of how we can mine our web data. And one of them was how we built emoji search and emoji predictions. For emoji search and predictions, we were able to learn the relationships between terms like unigrams and bigrams and particular emoji characters based on how they're used on the web and how users reference those emoji, and identify terms that when typed in a conversation could reflect that could be replaced by a particular emoji. And that's how emoji predictions work and emoji search works in Gboard today. Another feature we have is something called predicted searches, where we've built completely on-device models to take as an input the words that you're typing on the keyboard and predict search queries that we think might be relevant. So for example, if you say, hey, do you want to grab lunch today, then Gboard might suggest a search query, restaurants near me, so that you can find a restaurant and share it with your friend. The last feature in Gboard is GIF search, and this is one of the more popular features that users have been using. And this is built off of our core ranking algorithm. So we're able to scale and use what I talked about earlier with synonymy, with spam, with our core ranking functionality, and apply that to a restricted corpus within our image search, restricted to animated GIFs. And that's how our GIF search works today. So that's all I have for today. I believe we'll take some questions, perhaps.
Thanks, Rajan. Well, let's turn to some of the questions. I think we'll just go more or less in order that we received them. I've been glancing through them. A wide variety of questions. First one is, why can't we see the knowledge graph pane for President Obama when we search for Barack Obama election in Google? A very specific question.
Yeah, so maybe you're asking me to debug the query real time, but I think, ultimately the goal is to show answers that we think are useful for users given what we think they want for a particular query. So for Barack Obama election, I'm not sure today what a user might want, given that he's not running again for president, but perhaps they're interested in understanding what he might be talking about with respect to the election. And in that case, I would expect news articles to rank as opposed to his knowledge panel. Hopefully they do.
Okay. Let's see. How can you tell if a user found the results they liked versus they got frustrated and bounced?
Yeah, this is a really hard problem, especially when we start to show answers directly on the page, and and a user might not need to click to get the information they want. So this is something we're actively working on today to better understand and better develop metrics for this new world of search, where we're trying to provide answers, we're trying to be mobile first, and users don't necessarily need to click through to a page to get what they want.
Another one, specific technology or software involved. Are you incorporating word-to-vec vectors to understand the information need in Google search?
It's a big group, Google search, so I'm not sure who is working on what. So it could be the case that somebody's working on applying word-to-vec somewhere at Google, but I personally am not.
A lot of things going on at Google.
Yeah.
It's probably there someplace. Okay, are your changes and improvements at Google sometimes prompted by actual complaints or unsolicited feedback from users?
Yeah, this I think is a really good question. It is. We internally send reports of problems we've experienced in our own usage of Google to the team, and then we look at the feedback that we get from real users. It's possible for any user to provide feedback to us. There's a feedback link, I believe, on the bottom of the search results page. And we look at that, and that's actually what motivates almost all of the experiments we run and the improvements that we make.
Good. In terms of data mining tools, what tools do you use? Are they all internal, or do you also use third-party tools?
Most of the tools we use are internal. We use, we oftentimes write code from the ground up. We have our own libraries for data mining. We use MapReduce and some of the technologies we've developed over the last 15 years at Google. Every engineer, though, and statistician has their own approach. Not everybody does things the right way. The same way, and everyone takes their own approach to solving a particular problem, and they're free to use whatever approach or programming language they like, and yes, there are a lot of right approaches to do it.
Here's a question I actually have done myself, I think, sometimes. What about connecting the language word, presumably a search word, to a thesaurus, or would this just be too crazy?
Yeah, so, I talked a little bit about this. A thesaurus would be a very limited way to understand synonymy, simply because it's hard to understand the context within which these two words mean the same thing. So, for example, cat and cats don't even always mean the same thing, because cats can also be a Broadway musical, and proper names and so forth aren't really represented in a thesaurus that well.
Let's see what's next on our list here. We did the source one. Let's see. As we change in uses of language, if we look in Webster's dictionary, there are so many changes to words that never used to be considered words. It kind of like very old school English, I think. That word is still on at school in New York City. So basically, how do you keep up with the speed at which language is evolving, et cetera, et cetera?
Yeah, so it's great that we're able to crawl and index the web very quickly. So now we're able to crawl and index web pages within seconds after they're published, and new web pages use new language, and search queries, users use new language when they issue queries to Google, and we're able to use that data and keep our models up to date and fresh simply by refreshing our signals using newer data, newer web pages and newer search queries.
Just another question along with that too. When you say as soon as something goes up within a few seconds or minutes, you've crawled it. It assumes there are links to that page or something. Otherwise, how do you find something that is hard to find?
So, like, we can discover web pages several ways. One way is a webmaster is able to push a sitemap to us. Another way is that that page might be linked to from another page that we've already discovered. So most news publishers push us a sitemap or tell us in some way that a page was just published. So we're able to discover it and crawl it and index it very quickly, especially from the more popular, higher quality, authoritative sites.
Question about misspelled words. How do you deal with words that are intentionally misspelled? For example, company names where they come up with interesting spellings or variations on words.
Yeah, this is a challenging problem. We are able to learn those words by looking at what words are used on the web. So if it's a company name that's spelled a different way, we'll see that word is on the web, and we'll see that users refer to that company by that name, and understand that it must be a real concept.
A more general question here on artificial intelligence and sort of where it's taking us into the future. So regarding AI, you're making a learning system, correct? And if this is totally developed, what will the checks and balances be? And can this developing be considered a cyborg?
We're building a ranking system. There are certainly people out there that are building, like artificial intelligence systems and learning systems. I would consider our system to be a ranking system. Our checks and balances for our ranking system are, simply, are we doing the right thing for our users, and are we doing the right thing for the web ecosystem and the app ecosystem that we're built on top of?
And another AI question, why is Google obsessed with AI, or actually, do you think it's obsessed with AI?
I wouldn't say Google's obsessed with AI, but certainly machine learning and AI can help us solve really hard problems. Problems like, can we build a self-driving car? And these aren't just hard problems, but they're important problems in terms of what Google believes is important to work on for the next 5, 10, 15 years.
Specific question on Gboard. How do you measure how much the product has improved the user experience through machine learning?
So it's a good question. We were able to run evaluations similar to how we do it in search ranking. We run evaluations to see how easy it is to type using the app, and we learn from ourselves, our own usage, to see what our experience has been with the app. But no matter what product you build, having a good evaluation system is critical for knowing whether you're actually improving it. So that's one of the first things we set out to do with the keyboard.
And is Gboard available for Android?
Well, we also have a Google keyboard on Android, so we do have a keyboard on Android that you can get from the Play Store. It doesn't yet have some of the functionality that Gboard for iPhone has, but we're looking at seeing what the right products and user experience is for Android.
And Windows Phone?
I don't believe, I'm not sure, but I don't believe we have one for Windows Phone.
So here's a question. My understanding is that Google engineers prefer to use neural networks over other machine learning techniques like GBM. Is this correct? And if so, why?
It's hard to classify Google engineers in one bucket. At Google, there are several independent teams that would consider themselves to be machine learning teams, and each of them takes a different approach to learning. I'm not on those machine learning teams. We certainly use a lot of the research that they develop, but I think they would be the best people to answer that.
Okay. Just an interesting question. What are the main differences between Google search over a public corpus versus Google search over a private corpus such as Google Drive?
Yeah, the one big difference over a public corpus is that there's simply a lot more data, and you're able to use that data, such as like the link graph and usage of these pages, to better understand what these pages are about and how authoritative they are. One very obvious difference is if you're searching over a private corpus, the incentives for the publishers within that corpus are very different. So searching over Google Drive, you probably don't have to worry as much about spam or quality metrics as you would if you are searching over a public corpus where anybody can contribute content.
Okay, we have a few more minutes left here, so let's pick out a few more questions. Are you using machine learning as well to identify, improve, utilize sounds in search results for Google Voice search? If yes, what are the sources you're using for collecting voice inputs, and how do you collect them?
Yeah, we're experimenting with using machine learning in various products at Google, I think including voice. I don't know the details of what the data is that we use, but certainly we are experimenting with using machine learning in more and more products.
And what about the types of algorithms you use to scale to billions of natural language text?
Yeah, there's a large suite of algorithms that we've developed to scale to the web-size data and to search query size data. The Google Brain team has done quite a bit to be able to scale training neural networks to billions and billions of inputs. The search ranking team does quite a bit to make sure that the algorithms they build scale to apply to the size of data we have. But all of these algorithms are very different. They don't really fall much into a single bucket, so it's hard to group them. But they're all kind of unique and built from the ground up.
And how many of the new search features you showed us will be part of any newer version of the Google Search appliance?
How many of the new search features will be part of any? It's hard to tell. I don't know if I showed a new search feature. I think everything I showed is actually is out there in production today. So hopefully it's out there.
Okay.
And the Google Search appliance. The Search appliance. Actually, I don't know. I don't know very much about the Search appliance. I think to be clear, you're not talking about the app that you use on the phone. So I don't know.
Okay. Let's go. Maybe two more questions here, I think. As a UX designer, a big challenge with many application sites I'm involved with, helping design, is providing a comprehensive internal site search tool. Does Google make their full algorithm available when a website employs the embedded Google search?
Yeah, so there's a product called Custom Search Engine that anyone can use. It's out there and it's built directly on top of our core search algorithm.
Okay. And maybe one final question then. How does Google Search handle the deep web content? Very interesting question, actually.
Yeah, we don't do anything specific. We're built on top of the web that we can discover, and and we discover web content through, like I mentioned earlier, through sitemaps that webmasters might provide, through our link graph that we crawl. And then the same algorithms apply to all of our web content. We try to understand if a site is high quality, it's authoritative. When we try to understand if that web page is topical and fresh for our users. And if it meets the bar across topicality, freshness, and authoritativeness, then we think it's a good, useful page. We don't necessarily apply different algorithms for different kinds of content.
And we've got maybe 30 seconds. One final question, because this is a search-related question. How can new content break into high-ranking pages when it doesn't have links or other signals?
Yeah.
Perhaps it's a rich get richer situation.
Yeah, this is also a really good question. So another way to say this is like, does existing content get grandfathered in to ranking for certain queries? And part of our algorithm is actually focused on making sure that we can surface great new content that is published to the web. So this is certainly a problem that we had discovered or knew about for the last ever since we've had our search engine. So spent quite a bit of the last few years working to make sure that the best content ranks well, no matter what existed previously.
Okay. Well, thank you, Rajan. That was very interesting. And for those of you still listening, we will be sending out a link to the slides and webinar in the next day or so. So be looking for that if you want to review it. But otherwise, we hope to see you again, in a sense, or listening again to one of our webinars in the future. So goodbye for now from Stanford, and hope you have a great day.
Coding here instructions to what we believe are important for our raters to evaluate, and I'm going to just show you one section of this. These are your money or your life pages. So some types of pages could potentially impact your future happiness, health, or financial stability. We call such pages your money or your life. So we actually spend a lot of time training our raters to make sure that they value authoritativeness, high-quality content, especially for queries where authoritativeness, trust, and quality could make the difference between a great experience and a pretty poor experience in search. And this document, this kind of guideline for how we think about search, has evolved over time with respect to our thinking for what makes a good search engine. So recently, we've started focusing a lot on mobile friendliness and encouraging our raters to spend a lot of time evaluating whether a page is friendly on mobile devices. Does it load quickly? Is it easy to consume? And then beyond that, continue to focus on whether sites are authoritative, whether they if it's a retail business, does it get good reviews? Does it have a telephone number that's obvious, or contact information that's obvious on the page? So all kinds of properties that we think make a high quality web page are asked of our raters to evaluate. Now, these evaluations aren't used directly in our ranking function. They're used just to help us understand whether changes to our ranking. One of the problems we face simply building our web index is, well, which of the billions or even trillions of web pages that are out there on the internet should we crawl and should we index and keep accessible for our users? And then, how often should we recrawl these pages? And as we try to solve these problems, we look at the data in terms of how often these certain pages and certain sites are impressed and are clicked, and try to model and predict whether a new page that we're crawling is going to be one that would be useful for users in the future. So as you look at some of the features that we build into search and some of the experiments that we run, here's just a screenshot of what our desktop search looked like. I think about a year ago. It's probably similar right now. The query is Bakery, Durham, North Carolina. We actually evaluate every single component and experiment with every single component of this search results page. So on the left-hand side, you see a list of web results. These web results We run a retrieval algorithm where we retrieve web pages that we think might be relevant. We rank them, and then we display them in a manner that we think is consistent with what users would expect, and making it easy for them to interact with our search results. And every component of that is individually and holistically kind of experimented with. And I'll talk a little bit about how we go about that experimentation process. We also have ads on the right-hand side here. We run experiments with ads, as well as the UI and the look and feel of our search results page. The important question that we always ask ourselves in search is which way is up? What makes a better search engine? What makes a better ranking function? Or what makes a better UI for search? What features are good for our users? And the difficult problem with this is that there isn't necessarily a gold standard that we go by to determine what our true north is. What we've been able to do is, over the last 15 years or so, kind of solidify our vision for what we want our search experience to look like, and try to encode that in guidelines that we provide to human raters. And these human raters provide us feedback on our experiments. So what we're able to do is run experiments, provide examples of these experiment queries that are affected by these experiments to our human raters, and then they're able to kind of help us evaluate whether a particular change is positive in their trained opinion. And then beyond that, we run live experiments on real users as well. So I kind of want to show you a little bit what these. Let's see, how do we get to this tab here? I'm just going to click. I'm going to show you what these rater guidelines look like. Reloaded here. So it's kind of we're in. So today I'm going to talk about some of the problems we face at Google, and where big data is especially relevant to helping solve these issues. I'm going to focus on search and search ranking, and then talk a little bit about an app we just released called Gboard. Gboard is an iOS keyboard where we spent a lot of time kind of building from the ground up a keyboard that's able to predict what you type and autocomplete your words and is as accurate as we can make it. So we get billions of queries a day. Every day we see queries we've never seen before. We see about at least 15% of the traffic we receive are brand new queries we've never seen before. And we have to be able to develop algorithms using the signals and the data that we have to be able to find answers for each of these queries. And for what I'm showing you on the left here is the query, why is the ocean blue? And we've returned an answer from the NOAA's website that tells you why the ocean is blue. And behind all of this is our core ranking algorithm, which understands what users are asking for and is able to surface answers from the billions of documents that we have in our web index. Function are good, but the reason that I brought it up here is to show that there isn't really a single objective metric that we're trying to optimize. We're really trying to encode what we think is good in a search engine and hopefully iterate over time and get there. At the same time, though, we run live experiments, and we make sure that whatever we build has a positive, hopefully has a positive impact on users. So I'll show you like a little graph we put together. This kind of goes through, this data is from 2012, but goes through the process of of the experiments we run and at the scale of which we run these experiments, and the funnel through which we come up with ideas and evaluate them. So the top number there is 118,000. So we ran in 2012 118,000 what we call precision evaluations, where we came up with an idea to change our ranking function or our UI, and we asked raters to determine whether they thought that that change was good. And so they evaluate each result, and they say, you know what, this change I think is better or worse than what we currently have. And then we also run these side-by-side experiments where we ask our human evaluators, well, do you think the left side or the right side is better? Where the left side might be the experimental side and the right side might be what we currently have in production. And then they evaluate. And they evaluate based on these trained guidelines that we give them. And finally, we ran 7,000